So this next logarithmic equation is one where you can't deduce it down to a log equal to a log because there's going to be this constant here. So every single one of these questions, there's this number that isn't a logarithm. So you can't use log laws to make it a log equal to a log. It's just a log equal to a number. Okay, so to solve these, step number 1 is the same. You're going to state your restrictions if you're using them. If you're just plugging in your solutions and checking, you don't have to do restrictions. They're kind of just a time saver. Then step number 2, you're going to use your properties of logarithms still, but this is just to write it as a single logarithm equal to a number, right? Not equal to a log. Then you're going to rewrite as an exponential equation. Now there's an or there, but I'm going to ignore that. I'll show you after. Okay, and then solve and check your solutions. So here we go. This one already has a single logarithm equal to a number. So we need to change this to exponential form. What does that mean? Well, if you have something like log to the base a of b equals c, changing to exponential form means that you're solving for what you're taking the log of. So I'm solving for b, and then the base of your logarithm becomes the base of a power raised to the exponent c. So what does that look like for this one? Well, it would be x equals the base 3 to the exponent negative 2. So x equals 3 to the exponent negative 2. And then to solve this, 3 to the negative 2 would be 1 over 3 to the 2, which is 1 over 9. Now you always want to check it against your restrictions, which I forgot to do at the beginning, and I always forget to do at the beginning, okay? But I always remember at the end. So there's only one restriction here. The restriction is that x has to be greater than 0, and since it is, I'm going to say, yep, a ninth is probably going to work. And if I wanted to check it, sorry, that shouldn't have been a round bracket. That's a set bracket. There you go. And then if I wanted to check it, you're just plugging it in. The log to the base 3 of x, does that equal negative 2? Well, when x is a ninth, you'd have log to base 3 of a ninth. Does that equal negative 2? Well, you can check it by using your calculator. You could do log of a ninth divided by the log of 3, or 3 to the exponent negative 2. Does that equal a ninth? Yes. Either way, it's good to go. All right, next one. So this next one, I have 2 logarithms equal to a number. So I want to combine these into a single logarithm. So this would be the log of, since I'm adding, I'm going to multiply. The log of x times x plus 3 equals 1. Then I'm going to change this to exponential form. So I know I'm solving for the log of, so it's going to be x times x plus 3 equals what? Well, the base of your logarithm becomes the base of your exponent, or your power. Well, the base here is 10. Remember, there's always those hidden 10s that if they don't write it, it's log base 10. So this would be 10 to the 1. Now I'm left with a quadratic equation. X times x is x squared, plus 3 times x is 3x equals 10. I'm going to solve by factoring or quadratic formula, but regardless, we have to make it equal to 0. And then I'm going to factor. So I'd have x plus 5 times x minus 2 equals 0. And so that x equals negative 5 and 2. All right, again, I forgot to do my restrictions, but that's okay. My restriction here is that x has to be greater than 0. My restriction here is that x plus 3 has to be greater than 0, which means that x has to be greater than negative 3. Out of those two, the most restrictive is that x has to be a value greater than 0. So because of that, I'm going to reject negative 5, and I'm going to say that the only solution is 2. And then I could check it by plugging it back in. The log of 2 plus the log of 5, log 2 plus the log of 5, does that equal 1? Well, I could use a calculator, right? Log 2 plus log 5, or I could say, because it's adding, I'm going to multiply. This will be the log of 2 times 5, which is 10, and 10 to the exponent 1 is 10, so the answer is 1, and I'm good to go. So again, you can check to make sure. All right, last one. Last one, I want to make this a log equal to a number. What's wrong with this one to start? I have the log base 5 of x minus 6 equal to 1 minus the log base 5 of x minus 2. I don't have the logs on one side. So the first thing I'm going to do is add log base 5 of x minus 2 to the left. So I'm going to have log base 5 of x minus 6 plus log base 5 of x minus 2 equals 1. Now I'm going to combine these logarithms. So since they're adding, they're going to multiply again. Log base 5 of x minus 6 times x minus 2 equals 1. Okay, I want you to pause the video. I want you to put this in exponential form and solve. Go. So hopefully you pause the video. We're going to change to exponential form. So it's going to be x minus 6 times x minus 2 equals the base of the log is the base of your exponent to the 1. So then I get x squared minus 2x minus 6x plus 12 equals 5. And then I'm going to make it equal 0. So x squared minus 8x plus 7 equals 0. And I'm going to factor x minus 7, x minus 1 equals 0, x equals 7 and 1. Oh, I did it again. I forgot to do my restrictions. It doesn't matter when you do them. So my restrictions are x minus 6 has to be greater than 0, so x has to be greater than 6. And x minus 2 has to be greater than 0, so x has to be greater than negative 2. The most restrictive of those is that x has to be greater than 6, so I'm going to check my solutions against those. Since 1 is not greater than 6, I'm going to reject it, and I'm going to state that my only solution is 7. And again, restrictions only show you what you should reject. They don't show you that you're right. So make sure that to make extra sure that you're right, plug it into the original equation and make sure it makes the equation true. All right, if you're happy with that, stop the video and leave. Okay, you're done with part 2. If you want to see another option, feel free to keep listening. So what it is that it said step 3 was rewrite as an exponential equation. Some people just do not like that step. They cannot rewrite things as an exponential equation. But the other option's not great as well. The other option is that you have to change the number to a logarithm so that you can drop the logs. In other words, for this one, I'm going to change to a different color. For this one, instead of having it as the log base 3 of x equals negative 2, you want to rewrite that as a logarithm. So log base 3 of x equals, we want it to be another log base 3. So you have to think 3 to the exponent negative 2 is what? Oh, it's a ninth. So then you'd get log base 3 of x equals log to the base 3 of a ninth. Okay, what did I do there? Log base 3 of a ninth is negative 2. So I've changed my number into a log base 3 that evaluates to negative 2. Then when I drop my logs, I get x equals a ninth, right? I'm going to get the exact same answer. So for this one, you'd have log of x plus the log of x plus 3 equal to, well, I want a log base 10, but I want this log base 10 of something to equal 1. What's the log base 10 of 10? So the log base 10 of 10 is 1. So then when you look at it, I'll combine it to a single log. So it'll be the log of x times x plus 3 would equal the log of 10. So then when I drop my logs, I get x times x plus 3 equals 10. I end up at the exact same place, right? But instead of getting there by changing to exponential form, I've changed my constant to a logarithm so that I could drop my logs. So same thing in this one. This is very similar. You know, this one you could even do differently. You could say this is log to the base 5 of x minus 6 equals log to the base 5 of what? Well, 5 to the exponent 1 is 5. So it's log to the base 5 of 5 minus log to the base 5 of x minus 2. Then up to you, you could still move that log to the other side, so you could multiply it, or you could solve like this. You could say that this is log to the base 5 of x minus 6 equals log to the base 5 of 5 over x minus 2. Now I can drop my logs. I get x minus 6 equals 5 over x minus 2. And then I'm going to notice that this is a rational equation, so I'm going to multiply both sides by x minus 2. So that I can simplify to x minus 2 times x minus 6 equals 5. And again, it takes me to this place. So by changing your constant into a logarithm, all that happens is that you skip the step of having to change to exponential form, but it gets you to the same answer. All right, so pick your poison, and we'll see you for the next class of applying exponential functions.